In this unit, we're going to look at sine, cosine, and tangent ratios of a right triangle. We're going to look at how to find the missing angle or missing side of a right triangle. We're also going to look at law of sines and law of cosines, which will allow us to find missing sides or missing angles of triangles other than right triangles. We're going to look at some applications. We're going to look at the graphs of sine and cosine trig functions. We're going to solve some trig equations, and we're going to look at trig identities. So we're really just going to kind of look at some different aspects of trig and understand what it is and how to use it. So the first lesson here, we're looking at the basic trig ratios, sine, cosine, and tangent. But before we can do that, we have to make sure that we know how to label the sides of a right triangle. So for these first three problems here, we're going to look at the marked acute angle, and we're going to label the sides adjacent, opposite, and the hypotenuse with respect to this acute angle that's labeled. So we're never going to be using the right angles when we're talking about labeling the sides of a right triangle. We're always going to be looking at one of the other two acute angles. So in this case, angle F is the angle that I'm looking at. And when I look at angle F, the first thing I always look at is the hypotenuse, because the hypotenuse is always across from the right angle. So I know that this has to be the hypotenuse. And then the other two sides, opposite and adjacent, come from angle F. So I always say, okay, well, I have to go opposite or across from angle F, and that's the opposite side. And then adjacent just means next to. So the side next to angle F is the adjacent side. Now, the other side that's next to angle F is the hypotenuse, but that's always going to be the hypotenuse. So I always label that first and then worry about the opposite and the adjacent, because hypotenuse will always be across from the right angle. So again, looking at number 2, the hypotenuse is always across from that right angle. So this is going to be the hypotenuse. And then identify the angle that you're looking at, and angle R in this case, opposite is the side across from it, and adjacent is the side next to it. And then this last example here, look for the right angle. Across from the right angle is the hypotenuse. That won't ever change. And then looking at the acute angle K, opposite angle K is this side here, adjacent is next to it. So now that we know how to label the sides given a acute angle, let's look at the trig ratios. So we have sine, cosine, and tangent. And basically how these three things are defined is by those sides that we just labeled. So the sine of some angle is equal to the opposite over the hypotenuse. The cosine of an acute angle is equal to the adjacent over the hypotenuse. And the tan of an angle is equal to opposite over adjacent. So it's equal to the ratio of the sides in this relationship, the opposite over the hypotenuse, adjacent over hypotenuse, and opposite over adjacent. That's how these three trig functions are defined. Those are your ratios. So a way that we remember this is Sohcahtoa as like an acronym. So this stands for sine equals opposite over hypotenuse, cosine adjacent over hypotenuse, tan equals opposite over adjacent. It just helps us remember the different ratios. So looking at this first example, if I want to find sine of angle A, what that really means is you're doing sine of A equals opposite over hypotenuse. That's what it means. That's what the ratio is. So sine of A, you go to angle A, identify the different pieces here. So 13 is the hypotenuse because that's across from the right angle. Opposite angle A is 12. Adjacent to angle A is the 5. So if I'm looking at angle A, sine is opposite over hypotenuse. So opposite is 12 over hypotenuse is 13. So 12 over 13 is what equals sine of this angle. That's what it means. So if I'm looking at cosine of angle A, cosine is ka, So adjacent over hypotenuse. So adjacent is 5 over hypotenuse, which is 13. So 5/13 is equal to the cosine of that angle A. And then tan is equal to opposite over adjacent. So opposite angle A over the adjacent. So then we look at this next section. Now it's asking for angle B. So that means these two things will change, and I'm not looking at A anymore, I'm looking at angle B. So angle B, the hypotenuse will always stay the same because that's always across from the right angle, but the opposite is going to change. So the opposite is going to be the 5 now, and the adjacent is going to be the 12 next to angle B. So when I'm doing sine, remember sine is opposite over hypotenuse. So sine is opposite, which is 5, over the hypotenuse, which is 13. When I do cosine, cosine of B, oops, I put A up here. Cosine of B is adjacent over hypotenuse. So adjacent this time is 12 over 13. If you notice, see how these two values switched? So the reason for that is because sine of A is equal to cosine of B as long as A and B are complementary, meaning they add to 90. Cosine of A is equal to sine of B as long as A and B add to 90 as well. That's just a property. That's why it's sine and cosine, because they're complements of each other. So they're equal when they're the complementary angles. And then for tan of B, opposite over adjacent. So we have opposite, which is 5, over the adjacent, which is 12. And if you notice the relationship between these just flipped, because now I'm looking at a different angle. So let's do one more of these. So just identifying. So when we're looking at A, we'll start with A. Hypotenuse will always be the same. Opposite is across from A. Adjacent is next to angle A. So when we're doing sine, so sine equals opposite over hypotenuse. So sine of A is 15 over 17. Cosine, ca. So cosine equals adjacent over hypotenuse. So adjacent, 8 over 17. Tan, so toa. So opposite over adjacent. And then when we get to B, everything flips. So now the opposite is 8, and the adjacent is the 15. So when we do sine, or so, opposite over hypotenuse. Cosine is ca. Adjacent over hypotenuse. And again, these should flip because we're looking at the sine and cosine of complementary angles, or angles that add to 90. And then tan should be the flip of this. So tan is toa. So we go to B, opposite over adjacent. So that's it for that. So now the next question is, how is this helpful? So yes, it's one thing to know that sine of some angle is equal to this ratio, but how does that help us? So in this next set of problems, we're looking at finding the missing side. So right now, you know, if we want to find the missing side of a right triangle, you could use Pythagorean theorem, right? So if this is A, B, and C, you could do A squared plus B squared equals C squared, and that would get you one of the missing sides. However, when we're looking at these problems, I'm trying to find the side length of AB. So I'm going to put an X there. I can't use Pythagorean theorem because I have an X squared plus this, so x squared plus y squared equals 26 squared, which I can't solve. So this is where right triangle trig comes into play. It only works in right triangles, and we can use those trig ratios, the sine, cosine, and tangent, or Sohcahtoa. Because now we're given an angle, we have one side, we can use those ratios to find the other missing side. So this is only for right triangles. So I'm going to look at this in terms of Sohcahtoa. So one of those trig ratios. And I always look at whatever angle I have, either a measure or I have an x. So in this case, I have 38 in angle A. That's what angle A equals. So that means everything's going to be labeled with respect to angle A. So 26 is the hypotenuse. This is the opposite. And this is the adjacent. So when I look at deciding, should I use Sohcahtoa, well, I don't have anything on the opposite. So I don't want to use anything that has an O in it. So that tells me I'm left with cosine, because I have the adjacent and I have the hypotenuse. So we want to do cosine of angle A equals adjacent over hypotenuse, and then we're going to plug in. So we have cosine of 38. It's always cosine of the angle, or sine of the angle, or tan of the angle, equals adjacent. So adjacent is x over the hypotenuse, which is 26. And now we have to solve this. So we have a number equal to a fraction, because this is really just going to be a number. So if I put that over 1, I can then cross multiply. So 26 times cosine of 38 degrees equals x. This you can just put in your calculator, but make sure that your calculator is in degree mode. So depending on your calculator, if you just go to like mode, you can change it to degree mode. Just make sure that that's on. If you're entering degrees, you have to be in degree mode. Otherwise, you're not going to get the right numbers. So if you put that in your calculator, you should get 20.5 if we round to the nearest tenth. And that's going to be the length of AB. So AB equals 20.5. So let's try a couple more. So in this example, we're trying to find BC. So I'm going to call that my x this time. Again, we'll look at Sohcahtoa. Since we can't use Pythagorean theorem, we don't have two numbers. We have to have 2 out of the 3. We look at whatever angle is labeled, which is 65. This is going to be the opposite. This will be the adjacent. And this, of course, will be the hypotenuse, but I don't have anything on there, so I'm not going to worry about labeling it. So I know I can't use anything with an h in it, so that leaves me with tangent. So tangent of angle B is equal to opposite over adjacent. So tan of 65 degrees is equal to opposite, which is 12, over the adjacent, which is x. Put this over 1 because that's just a number, and then cross multiply. So we have x times tan of 65 degrees equals 12. Get x alone, which means divide both sides by tan of 65. Remember, tan of 65 is just a number, so it's just dividing by that number. So those cancel. We get x equals, put that into a calculator, you get 5.6, and that's going to be the length of BC. So that's the whole purpose of understanding how to use these ratios, is so that you can find a missing side. And then one more example, trying to find BC. So the length of BC, again, I'll call it an x. Start at your angle that has a measure in it. We have opposite. This is the hypotenuse. Remember, we never use the right angles. We don't ever want to take sine, cosine, or tangent of a right angle. It's always of one of the acute angles. So because this is always the side opposite the right angle, is always the hypotenuse. So those always stay the same. You don't ever use them. You always look at the acute angle. So then when I look at this in terms of Sohcahtoa, I don't have the adjacent side labeled, which tells me I'm not using either of those, and I'm going to be using sine. So it's going to be sine of angle A equals opposite over hypotenuse. So sine of 34 equals opposite, which is x, over hypotenuse, which is 18. Put that over 1, cross multiply. So 18 times sine of 34 degrees equals x. And just put that into a calculator. So we get x equals 10.1 when we round it to the nearest tenth. And that's going to be the length of BC.